I'm Chris Crone, and welcome to this short video on how to use CA Plan Analyzer to identify and include column index candidate. I don't believe that anything we'll discuss today is forward-looking or applies to a product that isn't already GA, but as usual, the standard disclaimer applies. We're going to start off with a brief overview of the scenario. Then we'll take you through that scenario using Plan Analyzer, and we'll wrap it all up with a summary. Let's jump right in and start with an overview of the scenario. As a DBA, your job will be to verify the index design of a simple native SQL procedure. The procedure has 3 output variables, as well as a simple reference to a table with 3 integer columns. There are 2 indexes defined on the table. The first is a unique index on column 1, and the second is a non-unique index on columns 1, 2, and 3. The SQL procedure executes with explain a simple select of C1, C2, C3 into the global variables from the table test_tb with an order by on C1. Let's jump into Plan Analyzer and see what it can tell us about this simple SQL procedure that contains a single select statement. From the CA Plan Analyzer main menu, we're going to select Quick Explain by entering EQ and enter. From the PPA Quick Explain menu, we need to make sure that we are using a DBA profile by checking the profile option as highlighted here. Once we have verified that we're correctly using a DBA profile, we hit enter. In the Package Catalog Data menu, we can see our collection ID is test schema. We move to the command line in front of the collection test schema, and we enter S and enter. In the Batch Processor Card Display menu, we can see the strategy that we're going to execute. We're going to issue an explain on test schema, and explain type is a current explain. Hit enter, and we'll see the results. Our explain has been executed, and you can see in the SQL statement detail report our SQL statement text. For this particular package, the SQL statement is select C1, C2, C3 into out1, out2, out3. Those are our 3 global variables from test_tb ordered by C1. We can also see our table name, test_tb, and our index, test_tb underscore C1, C2, C3 underscore IDX as our index that is used to access the data. As we page down through the report, we can see the SQL dependency analysis, and you can see that table test_tb has 2 indexes, test_tb underscore C1 underscore IDX, which is a unique index with 1 column, and test_tb C1 C2 C3 underscore IDX, which has 3 columns and is a non-unique index. As we continue to page down through the report, a series of useful design rules are displayed. In this case, we can see design rule 73, which states test_tb C1 C2 C3 underscore IDX is used, but there are no predicates on that index, and the suggestion is that you should use predicates on the index keys to allow a full matching index scan. As we continue to page down in the report, the first of a series of red flags appears. Maybe I have too many indexes. As you can see, design rule 1029 states that test_tb has 2 indexes, but our installation has a threshold of 1 as a maximum. The suggestion is that you remove some of the indexes from this table so the threshold is not exceeded. Now, to be honest, 2 indexes is really not too many, but for the purposes of this example, we have a threshold of 1. paging down another time, we can see a second red flag. My indexes have keys in common. Design rule 1054 states that we have multiple indexes defined with the same index keys. And as you can see, recommendation is, if possible, consider redesigning these indexes to eliminate duplicate keys. This is a little bit more helpful. We have a third red flag and a recommendation that solves everything. Physical Design Rule 1083 states that we have table testtb with index testtb underscore c1 underscore idx, and it has the same keys as index testtb c1 c2 c3 underscore idx. As you can see, you have one index with just column c1 and another index with column c1, c2, and c3. A recommendation that helps resolve this issue of too many indexes. We need to alter the unique index by specifying the include parameter for the keys in the second index. That would be C2 and C3. And then we need to drop the second index. The design note on the previous page indicated that we should alter add include columns to index testtb underscore c1 underscore idx. Unfortunately, DB2 does not support that syntax in a single SQL statement. You would have to actually issue two alter index commands to do that. Another option would be to drop the unique index and then recreate the unique index with the additional include columns. And I show that in the syntax here. Also, you should note that you need to drop the secondary index, the non-unique index, because it's no longer needed. When you drop this index, you'll invalidate the SQLPL procedure because it has a dependency on that index. Please note that DB2 does not support creation of a unique index with a deferred status. Therefore, this process cannot be done in an online manner. You will suffer some sort of outage. After the change has been completed, we can go back to our SQL dependency analysis page in our report, and we can see we only have one index, testtb underscore c1 underscore idx, with 3 columns. The rest of the recommendations regarding extra indexes are no longer there. So let's summarize what we've learned. Indexes can provide dramatic improvements to the performance of queries, but index maintenance is overhead, and that's the concern that was voiced in the recommendations and design notes. As a DBA or an application developer, you need to be aware that index maintenance is overhead. Every insert and every delete will update every index on the table. Update itself will update an index if the index contains the column being changed. Indexes are very easy to add and very difficult to remove. So analysis should be done upfront to cost justify any index prior to creation. As we've demonstrated, you can use the Broadcom CA Plan Analyzer to help identify opportunities to improve index design. Thank you.